All right. Okay. New Cerebral Hangout. Welcome. There's not that much on the schedule today, really. It's more like just what's happening in the community and with the project. I have a crazy demo to show off, and I don't know if we didn't. Yes, Alexei has been doing some crazy stuff as well. I'm going to mention some of it, and he can jump in if he wants to share some more stuff. But I thought first I could mention the status on the .34 version. It's really good to have like Chris's project, like a Fricky's project, because it's really complex. It has lots of nested paths and async and sync and lots of stuff going on there. And it's kind of like if their application works, every application works. And currently it doesn't work on the latest version. But there's just a small bug there. So I'm just waiting for some feedback from him, and we should get this thing out the door. Yeah. Okay, cool. Any questions related to the latest version, or should I just move on? Let me move on. Let's see, I will need to share my screen here. Share, oops. And, oh, but like that. Okay, cool. So I've been working on this idea. It's kind of like I've been thinking about how we do coding, like what's it called? I've been a bit of a philosopher lately, because a lot of the code we write is really just describing stuff. So it's not like we do not do computations and stuff. We just describe how our UI should look. We describe how our state changes should run and stuff like that. And all this, it's all these describing things. And I thought about what other people do related to coding, like in the game industry. They do write a lot of code, but they also have tools that are not code at all, like creating behavior, like AI behavior, and building their worlds and stuff. They have application, or they have visual tools for doing that kind of stuff. So I thought about, would that even be possible in JavaScript to use visual tools to create an application? And I'm not talking about creating a web page, because there's lots of tools that does that already. But it's more in terms of creating components, composing them together, hooking them up to a central state store, and also kind of like visually creating with Cerebral, its signals and actions. So I thought I could just show you this thing. It's very experimental, and there's so much stuff that needs to work to even make it a real thing. But it's more for fun, how we can think about creating applications. It doesn't need to be only code. So what you see here is a components editor. And it's really, really ugly, all the buttons and stuff, but I'm going to try to explain it. What you see on the left side here is a component, and I can give that component a name, some component, and I can add properties to it. So for example, maybe I want to be able to pass in some text to this component, and I can type some text here. So here I kind of like add all the props, and I give an example of what that property can be. And what's kind of cool about that is that you can, by looking at the example, you know what kind of type it is. So you could actually create like the React prop type, just looking at the example. Because a lot of projects spend a lot of time defining all these prop types. It's really boring. And then we have our DOM tree, actually, or our elements tree. So currently it's just a div, and I can change that tag to something else, and I can give some text, hello world, like that. But I'm also able to bind things here. So instead of typing the text, I can hit this checkbox, and I can say props.text, and then the text up here is the text from the property I added. So this is kind of like visually creating bindings between properties and in this case, the text of the element. But I can also go in and I can add like styles to this. So I can say color red, and I can create a new selector here. For example, I want to add an active selector, which means that the color should be green. And what I can do here now is I can bind this class name here to a property. So I can say props.isActive, for example. If I add that property is active and set that to true, then the text becomes green. So the point there is it's really ugly and it's kind of crappy to click all these buttons and stuff. But the point is that I'm kind of like visually creating this stuff that we usually need code for, but we do not really need code for it. The question is it better and all? Do you need all the flexibility and stuff? But anyways, that's how it works. And then I can add new nodes to this, and I can say haha, and I can add another node saying woohoo, and then I can just drag these nodes up and down like that. And I can also add like the and I can also add like the child node here. So let me just refresh here, and I'm going to show you something kind of cool. So I'm going to create a list item, and this list item is going to take a name, or let's call it user item. That's more fun. User item, it takes a name, let's say whatever, and it's going to take it's awesome, and that's going to be true. Then I add a node to this, and I have like I want this to show the name, and then I want to add a selector here, and I want to say awesome, and I add a style, for example, background color, and it's red if it's awesome, and we bind that to the props is awesome, like that. Okay, now I'm going to save this, and then I'm going to go over to my project. So this is like the component section here is only stateless components, and then I can move over to my project, and I actually need another component here. Let's see, just a wrapper with a child node, and let's add some padding here. Padding 20 pixels. Let's save that. And now over in my project, I can add the wrapper. And what's kind of cool now is that I can take a look at my state tree here. All of this is just shoved in here, so it doesn't make that much sense now, but I have like a state tree here, and I have some users. And what I'm going to do now is jump to my project. I'm going to add a list node, and this list node is going to be my array of users in my state tree. So I bind it to state users, and then I'm going to add the user item component there, and I'm going to say that the name of this component is going to be bound to the item in the list and the name. Now I get the names there, and I'm going to bind the is awesome to item is awesome. Then I kind of like bound this stuff together. And this is kind of like the core idea of it. It's like, what if you could create a set of stateless components? You could actually compose them together. You could define your state tree, and you could do similarly to like signals and actions. And you would actually be able to build an application using like a visual tool like this. And the big problem is you always want to do something that does not conform to how this works. So it definitely needs like some escape hatch to allow you to also write code. But again, it's just an experiment. It's just, okay, would it be possible to do something like this? And what's kind of cool is that the problem is you can create a tool like that for JavaScript in general. But with Cerebral, which has such a strong concept of state changes and what is your state, it would actually be possible to do it. And what's even more cool is like all this stuff I show now is just descriptions. It's just objects describing your application. It doesn't run anything. It's just a description. And what you could do is you could hit like a button, publish or something, and it will send this description to the server, and it would transpile it into actual code. And then it would run your actual application on a different tab or something, and there it would run. And then if you did changes to your application there, it could use WebSockets, for example, to send information about the signals and stuff. And you could even have the debugger inside this application creating tool. And what's even more cool about that is that this is just a description of your app. So it doesn't matter what it transpiles to. So if there's like a new hot view library, it would be possible to just change out that part. And you could transpile it to React Native or whatever. But the point is that it's so simple what we're actually, a lot of the things we do are very simple, like creating a UI structure, giving it styles. State is also very simple, especially now we're just using objects and arrays and stuff. So it seems so, yeah, it should be possible. But yeah, so I just wanted to show that it's still just a crazy idea, but yeah. Looks cool.
I think it's awesome. Yeah. Even just from my like documentation or sharing with the team to give another view as to what's in this application. How does this stuff behave? What are its expectations? Like, I think even just from that angle, like you see a few projects kind of popping up, like kind of like sandboxed component playgrounds and stuff like that.
Mm-hmm.
I forget what the latest one was, but yeah, it pretty much like gives you a component kind of in its own context, and you can pass props into it, and it will render it on a page, and will show you what it looks like in different states. It seems like even with just that kind of use case, like would be really cool, a cool way to describe like what do these components do. But like obviously the vision with something like Cerebral makes it much more expansive, because you can go beyond just props into a component and rendering it to, like you said, like global application state and signals and things like that, which makes it even cooler.
Yeah, and it's also a matter of because we have a lot of tools now to help us write better code, like we're bringing in typing and stuff into our code. But if we had like an abstraction over our code completely, that would be like this crazy abstraction that would really help us do the right thing with our application. Of course, it's a lot more restricted, but that's the big question. Is it too restricted, or would it be possible to do something like that? but what I'm at least going to do with this project is build the components thing there. So if you want a project, you can build your stateless components inside, and these stateless components should not have like other libraries and stuff. It should just be UI structure and styles. So for example, if you want to use moment, you should use that from your application, and using that in your application and pass in the correct date to your stateless component. Your stateless component should not be the one formatting the date, for example. So it's just UI structure and styles. And people think so differently about how to build components, but this is one requirement for this to work, is that it has to be completely stateless components. But what's kind of cool about it is that if you create it here, you can do it very fast and visually, and you get the documentation right there, and you can search for all your components, and when you hit a button, you transpile it into a components project that you can require into your main application project, and then just start using the components. That's kind of cool.
Yeah, even just scoping it to that would be very valuable, I think. Because I guess it ties in nicely to your material, what was it, industrial design?
Yeah, it's actually
yeah,
from that, because because you often wound up in these discussions on what is like what scope does a building block in my application have, like what is the scope of a component. But if you force your thinking into completely simple stateless components, no dependencies, only UI structure and styles, then it's a lot easier. And then everything else has to be in like your application project. It's a lot easier to identify and scope your base components, because suddenly you're going to create some tabs, and suddenly you get some internal state in those tabs, and suddenly you get moment into your into the components, and suddenly it just gets you can't separate what's in your application and what's in your components project anymore. But this is like we are doing this now at that startup I was talking about, and it's really interesting, and it's like an iteration process, and I hope to write some more about it, because it's really, really nice. We are super fast at implementing stuff doing it this way. It's crazy, and we would be even faster if we had a tool like this. So maybe it will.
It got me thinking of like, you know, there's like Bootstrap and Material UI, which try and do the same thing, but like on an even more generic scale. And then like what you're doing, which is like still specific to your app, but separating out the stuff with behavior versus the stuff that's just presentation.
Yeah.
And splitting those off into their own UI library and having just stateless components. But then I started thinking like, well, if you really do the UI library right, like there's going to be other projects that need an icon component and other projects that need a header component, right? Like at that point, if you do that right, that UI library, like yeah, it's kind of unique to your project, but also at the same time not really at all, and it should be reused beyond that. So that's kind of interesting too. But then at that point, you kind of get into Bootstrap or Material UI territory, and then like in order to make that reusable, then you need like a theming thing, and then maybe that's where it gets hard, is like you want to change the padding or you want to change the theme, and maybe that's where it falls apart. So maybe just not trying to do that, maybe you can't reuse it maybe as much across projects, but you still get more reuse than we have now, which is almost none, where you just everything's mixed together and you rewrite for every project.
Yeah, that's very true. And actually the theming part is something we are looking into now actually. So but yeah, you're right, you can use it across projects, but also the fact that very often when you implement something in a project, you code UI structure, styling, and like business logic at the same time. And then you jump back and forth between all those three things. And it's kind of a messy process because you're actually trying to just get the shit to work. And then you have to sit down with CSS and you get crazy. But if you have this strong separation of defining UI and styles one place, and when you work on your business logic, it's just using those components. It's not about styling or UI structure at all, really. It's just composing those components together and hook them up to your business logic. So that's also really nice that you do one or the other. Because, yeah, I have been very frustrated working on some projects where it's all just a big mess.
But you guys aren't tempted to cheat? Like, say you're writing some component and you realize that it needs some of these more fundamental building blocks, then like instead of going and creating the issue in the UI library that, hey, I need these kind of basic components before I can do this thing, like you could just write, React.component and create it right then and there.
Yeah.
And move forward. So in a way, it kind of does slow you down maybe a little bit, but in the long run, it makes you faster.
Yeah, and that's also a really good point. It's about a bigger process. It's not only you as a developer, but like in the startup I'm working at, it's like nothing gets implemented in terms of UI before the designer has defined everything. So everything's specified. So you won't get any surprises implementing it. It's there. It's all the wrappers with the padding and margins and everything is specified. But yeah,
so that behavior-wise, you must figure stuff out as you begin to implement, right? Or is he smart enough to actually think of everything?
Oh yeah, like yeah, no. It depends. It's he's really good at identifying like different states on things,
which is one of the hardest things.
Yeah,
that's like happens to me all the time. It's like, oh, I didn't think about what would happen when this happens, and then that changes like how you implement it even.
Yeah, that's a really good point. Yeah, there has been situations like with he didn't know that, okay, when you click this button, we're actually going to talk to the server and we want to show a progress bar. And then it stops because the designer has to design how that should look. And then we just use some placeholder thingy. But we make it really ugly so that it will never be passed into production because it should be the designer that decides how that should look at the end of the day. But it's really hard. It's really hard to get that process right, and yeah. So how do you guys like do components? Do you implement them? Do you kind of like you get like an overall mock-up of what you're going to like how the end result is going to look, and then you just start implementing and create components as you create signals and actions and just do it all at the same time?
Yeah, at my work, we usually they point to a web page. It should look something like this, and that's it. So there are a lot of surprises, a lot of conversations as the project moves forward. So I think this slows things down a lot, actually. So I'm working on the project for myself only, and then I get feedback. I have to do like PNGs and mail them to them or something, or on Slack. So it's slow.
Ah, okay.
So this idea you have, it's great, because then they could create the UI structure themselves to see. So what about like buttons and forms and that sort of stuff in what you showed us before?
Yeah. So basically, what you can do is define like so you don't have any, for example, a button. You can define a button, and you can add properties to it, like we added styles. You can also add properties to a button, so like disabled state and all that stuff, and you can bind that to the property of the component. And if you need, for example, something to happen, like typically on click, you would just specify that. That's not implemented, but the idea was to just say that, okay, this is going to be a type of signal. So on click should be a signal, and then you will be able to bind not only state to these properties, but you will be able to select a specific signal. But when the scope of the project is just creating the base components, the stateless components themselves, you would just say that, okay, this will require a function. So you can't really, well, you could, it would maybe be possible to write, like create a function as a test property, and then identify that as a function that should be passed in. But like with forms, like everything that's defined in the state tree and all the signals and stuff, that wouldn't be part of it at all. It would just be how you would, yeah, you wouldn't like create a form component. Maybe you would create an input that also takes an error prop, which would be displayed underneath an input if it was passed an error. But you would not create compositions like forms with inputs and stuff like that. It would only be like base components, and then you would have to kind of like a form is a composition of multiple components. So that would kind of like be in the main project. Yeah, it's a good question though. We actually talked about this because we've been discussing the level of abstraction between components. So you have like the top abstraction, that's where you actually bind the state and signals. And then you have the lower level components, which is like a single button or a wrapper or whatever. But then you usually need to put multiple of these base components together to build like a form, for example. And the question is, where is this thing? Yeah, are there abstractions in between, like the base components and the app components? And it's very, very difficult to identify all this stuff. But we have a concept we call composites. So you have all the base components, but then you can create composites. And a typical example of that is, for example, a comment. A comment would be like an avatar. It will be the comment text. It might be a date and the username, something like that. That is like a composite because you have the avatar, you have the comment text, and you have some kind of header, which is the name, and you have the date. So that's basically all the building blocks we use. It's a component which does not compose any other components. It's a base component. Then we have composites, which is a composition of multiple base components. And then we have the app project, where we use these composites and base components to build the actual application, if that makes sense. Sorry, I'm rambling on here about all this stuff.
Yeah, it makes total sense.
Yeah. So, but I think it's very confusing now how to build components the correct way, because there's so many ways to do it. And when there's so many ways to do it, like you will see every possible way to build a component out there. And there's no like guidance from Facebook. I don't think they even themselves have like, okay, this is the way to do it. So, but what's really nice is when you find these very strong concepts, you can start to build abstractions on them, and you can build tools on top of them, because components are so wide and open and so low level, so you can't build any tools right on top of React, because there's so many ways to do things. But when you say, okay, they have to be stateless, they have to be base components, they can't compose other components, when you give those kind of rules, then suddenly you can start to imagine some tooling on top of them. At least that's the idea.
Yeah, hearing you talk about that, I feel like probably what we don't do enough of, or at least what I think is like, we don't write enough of those dumb base components, because we think, like, I've thought this before, like I write something that's like a React component that's an input, and then I look at what it's doing, I'm like, all this is doing is just wrapping a native input. Like it doesn't, so like why don't I just use the regular input? But like if you embrace that idea fully, where each thing is wrapped like that and they're composed together, then you get those composites. But as long as you don't have those base things, you're never going to get the composite, because each thing will need to rewrite the, if you haven't wrapped it, you need to rewrite it in each component.
Yeah.
It won't be the same. It won't be reused across everything. So.
Yeah. And what a lot of developers end up doing is creating these really, instead of building many base components and creating these composites inside the application project, they create this huge component which takes 30 props.
100 props.
Yeah. And they're supposed to do everything. And for every little change in the project, you have to go in and create some new prop, which usually has a new if statement, and it just gets out of hand. But if you just create these basic components and just compose them together inside your project, you're a lot more free to make the adjustments you need when you get new feedback and reusing them.
I guess if you find you're composing the same ones together in the same way, like once or twice, then you move it out into the UI library.
Yeah.
Right. Yeah.
Yeah. So and another way we also think is in the components project, it should not be about the domain of the application. If we feel a need to, for example, create a comment component, that is domain specific. It's something that understands what our application is about. So then we put that in the application project. But like a header or a title or a wrapper or a button or and what we also notice is when we start to get into domain-specific components, then they are usually like composites of things. So there is this, and to keep the structure and everything, you have to create these rules, and it's really, really hard to create these rules.
It sounds like the same things that make refactoring code difficult, right? You need to identify the correct responsibilities of things, and as they change, you need to keep those responsibilities distinct and extract things and break them apart and not have assumptions about what context they're used in. It's the same, just like all the problems with code, with like code, right? Just for UI as well.
Yeah, that's true. That's true.
Like, you know, it's the same thing. Like, oh, I have a function. I need this to do more things. Let me add more arguments to it.
Yeah.
More, you know, it's like, well, that's not really a solution, right? It's the
Yeah.
same thing with props and um, like use two smaller things and compose them together. Make, you know, your special button. Don't make a header button component, right? Like compose the header behavior with the button
Yeah.
together and to create this new composite. It's the same thing with regular code, right? Like don't inherit some class in order to get that behavior. Have two separate things that you can compose together.
That's a really good point. And just visualizing your component as a function that takes arguments, then you suddenly understand why you're doing it wrong when you're passing 30 props. Because you would never pass 30 arguments to a function. That's a really good point. Huh. Awesome. Should we just move on maybe? Or does anyone have anything they want to share with the group? Okay, cool. I thought, yeah, I don't know if you, Matthias has done a lot of great stuff on the forums lately, making some updates there. I've been using forums quite a bit, and they work really good for me. I just wanted to ask the question: how are you using the forums module, and is it working out?
Yeah, I think it works great because before I used Cerebral forms, there were a lot of encapsulated state to the form component. But now it's a lot easier with the Cerebral forms. So I have it's like 40 different customers that have totally different forms for stuff, for like registration and that sort of thing, file uploading, dates, whatever. So there are huge forms sometimes. And I worked with, I've used it before with like jQuery and PHP, and that was a mess. So now we are porting this to like Node.js and using Cerebral, and I'm very happy about it. So it's worked great. It's I think I'm pretty new to JavaScript, so I think that it's a lack of experience for me, but I'm getting there. So yeah, so it works great actually. And now we have this thing that it likes 40 inputs, maybe 40, 50 inputs, and they should only hit the submit button once, and then it should scroll up and, you know, show red lines and whatever. And Cerebral had made it. Yeah, it's great. So basically, forms are hard. I think it's like very hard, but Cerebral helps. Yeah.
Yeah. I like the fact that it's actually like the form is driven by state, kind of like everything's described in the state, so you don't even need well, usually you want to use form elements and inputs and stuff, but it would actually be possible with the Cerebral approach to create like a new concept of forms, like using a canvas or something. Just go completely crazy, and you can nest forms in, like you can't use a form element inside a form element, but with Cerebral you can actually do that, just not use a form element, but like you have your submit signal and state structure in the state tree, and you just create elements you need for it, and the signal and the state description or the form description inside the state tree will handle all the validation and all that stuff. And it's like thinking the other way around, because natively you have to put all the validation on each input, and you depend on the form and all that stuff. So it's really interesting to see what you're able to do with it. And I especially like the validation stuff. It's really nice to just put it in with like the in the state tree, and then you can just put it in there, and then later maybe you can create or the components for showing errors and stuff. So so you kind of like at least you have the business logic for handling the form, and then it's creating the UI next instead of doing everything at the same time.
Yeah, and also the rules flexibility to say that this input is dependent on this and this input, and you create rules around them, and then it just works. So I think it's great to have that abstraction to move it out. So the discussion on we had a discussion on, I don't know what it was it kittens and stuff. I think that what I really like about Cerebral is this, that the state is out of the components.
Yeah, I agree, and that fact has made it possible to do so many cool things, like forms, like it works here is one example, and debugger, and now this crazy experiment I showed you, we can like do that without this separation. So
that's why I was surprised to see Redux people kind of moving away from that. But I guess understanding what they were saying was like the problem there is when they have really complex like entities, really complex data structures, having that stuff in the same place in the one object with the rest of your state. For some reason, it wasn't totally clear to me, but for some reason they felt that created problems, which is why they wanted to go back to some component state.
I think that the thing there was, you saw me wrote a comment there, and what I think he meant there is that they're using relay, and relay doesn't have any concept of
I see.
State. So
it's pretty much like, we need GraphQL and relay, therefore like we can't do this approach with that. I see.
And
so to me, like that would be like, what I would say is, how can we make GraphQL and Falcor and this stuff work with a single state store, not stop using a single state store because these things don't work well with it. But I understand they probably need to get their code to work and like deliver features, and you can't rewrite GraphQL or whatever in the meantime.
Yeah, that's very true. And the biggest problem with having like an external state store, which is just objects and arrays, and we talked about it many times, but relational data, it's not easy to do at all. It's actually really crappy compared to, for example, I've been working, have you heard of Parse? It's a project Facebook bought, but they sold it again, or it made it open source actually. And the API is based on Backbone. And what you do there is, for example, if you have a post and you add a comment to that post, you kind of like just work with a post, and you add a comment, you just add the user to the comment. You don't reference like any IDs or anything. You just grab the user and just naturally put it wherever you want, and it will automatically create the structure underneath to understand the relationships. So even though you put the user there, you're actually just creating a reference to a user. But the point is that
that already does more than Backbone did.
Yeah, that's true.
Like
that's
handling the relationship, whereas Backbone didn't even try to do that.
Yeah, and actually, I want to maybe on the next Hangout I could show how this Parse API works, because it's very nice to have this natural way of creating relationships, not having to think about looking up IDs and all that stuff, because we have to use computed and all that to make that kind of thing. Well, computed is on the output of it, but we're still on the input. We have to think about all these IDs and references ourselves, and it's really hard to do, and it would be very, very nice to figure out how to handle that in a good way. Like Falcor is one example, but maybe it will be possible to create a new model layer for Cerebral, which could be based on Baobab, but it has some extra logic to how it handles mutations. So you could kind of like have pointers and stuff. But
I find that I don't want to use the relationships as much on mutations. Like I would kind of rather be explicit, because like at least in Cerebral at that point you have the full state store. So if you need to go set an ID or look something up, like you have everything that JavaScript has to map over stuff and grab what you need. And being explicit there and kind of a little bit more verbose, I find has worked well for me. Where the pain is, it's on the when you want to do when you want to present relational data to a UI, almost like for a read only, where it's like, for your example, like, oh, I have a user and I have some comments, and I want to give one object to a component to display the user, and then to list underneath them all the associated comments. Right now, it's a little clunky to do that, and especially like with computed, like when you're dealing with entities, like going all in on like computed and everything be derived, like so. I've been looking into like normalizer and things like that more, because like in our app where I'm spiking on converting old Backbone code now to Cerebral, and like as a first thing what I did is just serialize all these Backbone collections and models and just stick them in Baobab. Did I say that right?
Yeah.
Baobab. And but the problem is like all these entities now, which are Backbone collections, have a ton of nested data, which is not good, right? Because as they mutate and update, you're not doing it by reference. They each have their own copy. So probably what I want to do is go all in with entities and make everything by reference, and then you need to have everything be computed, everything be derived from these entities. So like we kind of cheat now. A lot of what we do is like the same data that we pull out in our decorators is just grabbing by key the entity as the data exists in the store, right? So, and just passing it to a component. But if we were to be more careful about this, probably what we should do is have a completely normalized entity that is the actual data, and everything that's coming in to the UI should be computed from that for whatever that component needs. I think. I mean, if it's small enough and you don't have relational data, you can get away with it and have how your data is stored in the store and how it's displayed in the UI be one-to-one, and it works until it doesn't. and then you need to do this stuff.
Yeah, I worked on that entities project, like a module, but it works, and it was like interesting project in terms of trying to create these or understand these relationships, but it's still just, it's too hard. It should be simpler. But yeah, it should be some way to like, because you have to define these relations, use special objects like to identify, okay, this is a pointer, so I should get that data from there. So it needs, and the question is, where should this logic be? Like,
have you seen Normalizer?
I've only heard about it.
Yeah, so it's pretty cool because it solves that problem largely, where it's like you define a schema for a resource for data you're getting back. So you would say, here's this endpoint, and then like in your middleware in Redux, whenever you make an HTTP request, you get the data back from the server and you feed it into the schema, and you say normalize. And that's where you define, oh, this user has comments, and the comments will contain these IDs, and it normalizes everything. So it will replace the actual nested objects with references to them. And it does all that work, and it can be nested and nested and nested and handle all the different relationships. But so then you have everything kind of like in this very normalized way, but then you couldn't display the data right as it's stored after being normalized by normalizer. And then you need to transform that for your components. And I think for Redux, that's where reselect,
yeah,
that's their solution. And for Cerebral, I don't see any reason why we couldn't do that with computed. Yeah, the only thing that I think we would need to make it nice would be to embrace using props in computed, so that any component that wants to display that data can use props data that it's passed and also other data in the store too.
Yeah, because that's really interesting to, like you say, you can pass some data into a schema, and that schema could also produce the computed stuff you need. So kind of like you create a schema, and which kind of like returns a function that takes the data to put it correctly into the state, but it also returns a set of computed stuff to grab that data correctly. So you don't have to use two different projects. It could actually be one thing with Cerebral.
Oh, that is cool.
Yeah.
Yeah, because we could do both. We could handle normalizing, and then we could also have a thing that denormalizes back.
Yeah, exactly. So so computed is the denormalizer, and then we're just missing.
Oh, that's totally right. Because if you have the schema, then we would have to just write the module to say, given this schema and given this data, this is the function that I need to turn it into the view.
Yeah.
The data that the component. That's very cool. Yeah.
Yeah, it's interesting. We should. Yeah.
But I think even so, even just with the first part, if we could, that's kind of on my to-do, is to actually check out normalizer. But given that with computed, I think you can get there. It's just that I don't think I or anyone else has really totally gone all in with like, and I think that's kind of what these guys were talking about, was like being more strict about the separation between entities in your state store and all the data that's derived from it. I think we cheat a lot, and everything's in one place. But I think similar to almost like stateless components, right? If you isolate where this data is, where it's coming from, and it's just passed down and it flows down to everything else, like I think similar with your entities, if you isolate where the source data is to these entities and everything else is just a derived view that's computed from that, I think lots of problems go away.
Yeah.
But it takes more work initially.
Yeah. Yeah, it's really interesting. And this normalizer thing, is it specific to Redux, or is it like just a converter?
Yeah, it can be used anywhere.
Cool.
Yeah, let me find the link.
Yeah. Yeah, we should just try that. It sounds like a really great project. We should just wrap it and then add some computed magic to it, and then maybe you could just you create a post, and then you get based on the way you define the schema. Maybe we have to change that a little bit, but the way you define the schema, we can actually create a dynamic computed function to grab whatever post you want. That sounds awesome. But does it handle
really cool.
Does it handle like, okay, you got this post and it has an user ID, but you don't have that user? You need to fetch that user. You still have to do that kind of stuff manually.
Yeah, I don't think it has. Yeah, I think you probably need it at the time that you run the normalize function.
Yeah.
I don't think it does async stuff. That would be really wow.
Yeah.
It would like batch up, right, that request for that user ID and wait until.
Yeah, and it sounds like out of scope for
right
normalizer.
I mean, Cerebral could do something like that because we have the entire state store.
Yeah.
So we could say, I have this other entity, right? I have this user entity, and let me look in the state store for that entity and wait and make a request until it comes back. And then when I have it, then I could create the reference.
Yeah. So you have, because that's the approach I've used many times, is like if it doesn't exist, you create a dummy object for it. So in your UI description, you just, okay, if user dot is being fetched or whatever, then display loading user, or so that you never have an empty user. You always have a user, but sometimes it's just being fetched. But sometimes you don't want to display that. You actually want to wait until you got all the data before you do anything in the UI. So
I think it's probably, I guess I don't feel that pain. Maybe I just haven't encountered the right case for it yet, but I kind of like, given any view, let me fetch all the data that I'm going to need for it and making sure that it's there.
Yeah. Because it's about,
rather than kind of doing it async, you know, like because Ember Data does a very similar thing where you can define properties on these models and you can declare them to be async. So if you're iterating over comments and comments have a user, you could say user is async. And if you're in your template and you're trying to render the username and it's not there, it will go off and fetch. And once the promise resolves, it will render it, which is kind of neat. But I think it's hard to do. I think it takes a lot of work, and like just being explicit about, oh, these are the user things that I'm gonna display, or these are the comments I'm gonna display. Let me make sure I fetch all the users I need before, just like at the beginning of your signal.
Yeah,
I think.
But yeah, but this was a really good discussion, like the normalizer thing and combining it with computed. We have to look into that. Definitely. Awesome. Maybe we should check out, because Alexei has been busy. He's been working on extracting the signals implementation into its own thing, and it's gone a bit back and forth because signals are so many, not so many things, but it's like signals, actions, and now we have the context provider stuff, and we have some options that we can pass in, and there are multiple things to this. But now there is a project called, let me share my screen here. Yeah, a project called Action Tree. And what I like about, like conceptually like about this, it's kind of like helped us to identify what we are kind of like, what's the core of the signals. And as it's stated here, it's a behavior tree for JavaScript applications. And that sounds so sexy. And it's kind of like what we're trying to do as well. It's behavior tree, decision tree. That's basically the same thing, but yeah. So now it's actually possible to get some of the benefits from the signals in other applications. And oops. And let's see here. Do I have that other thing? Because is it? Okay. Sorry. It's because, as I understand, Alexei, you created this because we are unsure of where can this be used. Like, is it beneficial for other projects to use this action tree, as it's called now? And this was one implementation where you use it to create a form. It's kind of verbose now, but it's kind of as I understand it, like say it's kind of like a proof of concept of how you can use the action tree to outside of Cerebral to build things. And it's actually really cool to see that it's working like as a concept. And that means also that we can make Cerebral just depend on this action tree implementation. So Cerebral is not really like Signals is not this rather complex thing with context providers and all this stuff. We are actually able to split them up so other projects can use them as well. But it was really cool to see how, especially using TypeScript, how short the implementation for Signals got. Because it's been like, I don't know for how long it's been in development, like the Signals, and then there were some decisions made, and yeah, it kind of got a bit messy. So it's really cool to see all that.
Looks like Alexi's got some notes here.
Yeah. You want to show something?
Is that the logic there?
Oh. Oh. So is that like your mind map of how Signals work? They are kind of like mind bending. Internal modules. Ah, awesome. Yeah, because that's a really good thing to it's a really good process of refactoring a project, kind of like identifying the core concepts, because it's become like this thing that we just put new things on top of. Now we can like make these different concepts totally pure.
Does anyone hear me?
Yep.
Oh, it was issue with my mic. I thought that anyone could hear me.
Yeah.
It's notes I have created when started to decouple create signal store signal factory file into internal modules. It was hard. Since that we decoupled it more into context providers in 0.34 upcoming, and I hope in 0.35 we could move it completely to Action Tree project. Oh, yeah, it's pretty. Execute tree only 50 lines of code, even including some comments here. We can reuse it for execution, for replaying signals like recorded, or for debugger. I think it will be cool.
Yeah, it's really, really great.
Yeah. And here form demo. Underlying is just oh, sorry. That's better. No. Something missing on my Windows machine. It's just stateless component. It use class only for references, and it expose just some props and callbacks. And in stateful variant, I got this glue where I'm passing props from state and managing callbacks with proof of concept signals created right here. It's all file that does signal run. It creates signals, it runs signals, it has actions and chains. Completely in one file, it got 100 lines, and we can see it live. We can see the just React with with just own state managed by signals created by action tree. We can even do async stuff. Post password restores password, and we can see here different outputs taken. So it completely that signals that we see in Cerebral, but in our own format or component. It was very interesting experience. Here just that three signals used in this demo form changed. That just unsets error state and copies input to state. I expose here directly set state function from component to actions. So action here can take input, output, and set state. It's just proof of concept. It can be improved to batch set states, to make sure that it's set before async stuff happens, like it's done in Cerebral. I have some issues with it right now, but I think we will be able to manage it.
Awesome.
Is that set state actually React's set state, or your own?
Yeah, it's actually React set state bound to component itself and passed to create signal function.
Oh, cool.
So action actually have access to set state function.
Wow, cool.
I want to show some TypeScript magic here too. We can see that here we use chain description for type, and it knows that we can have parallel actions here. But if we try to use copy input to state here, stuck. Nope, I think it's still my Windows machine issues.
It was supposed to give an error?
It's supposed, no, here it will be only runtime error, but such thing should, would create, it's compile time error. We couldn't have arrays in parallel actions array. Only actions and outputs, object describing outputs. Also, here is example 2. We can pass data that will be able on input. So
Oh, okay. So
We
you
can
say that.
see here IntelliSense
Okay, cool.
available fields. Also, it's type checked.
That's really cool.
Can be number because it's string. We have access to all of it, so it just generics in Typescript passed through templates. We pass it as additional argument.
Yeah.
Just defining which type of data action could take. Here I use the same template in input, output, and set state, but it's possible to define different ones. It's still thing to explore a better API for interfaces, but it really looks cool already.
Huh.
Also, TypeScript gives much benefits in creating library code base, because you couldn't forget some things just because you was not enough overthought it.
Yeah. But this is really, really cool. And what you basically have done is make, like, we try to help developers kind of define the flow of things, much like other abstractions do as well. Like, for what I mean to say is, like, signals has now become less of a cerebral thing and more closer to what observables are. It's like you can use it for many different things. It's still more abstracty, I suppose, than observables, but it's really cool to see that you can use the concept in other settings. Really, really cool.
Yeah, we can see here that core code here is only these 10 lines. Just taking paths while traversing branches returned by static tree analysis. And this part just checks outputs to take passes, and also this does merge all output gotten from actions, and it merged to input to payload that pass to next actions that should be run. It will be interesting to check this code with Freaky examples. I think I will create soon branch for Cerebral, which will use this project, and we can try his
his project, yeah.
Maybe we'll see some differences, and maybe it will require some breaking changes here, because I tried different scenarios here, and looks that current state pretty solid, but not sure 100%.
But that it will be interesting to see.
Yeah, I want to test it.
Yeah.
Because all latest edits on 0.34 branch made by Freaky is directly related to this file. Also, I want to note that execute tree doesn't run actions at all. It just uses resolve action result function passed by client of this library. It can decide if we really actually need to run or action, or just use recorded ones and resolve just a pass and payload. Action result, it should resolve action result, which is just object with pass and payload. Payload doesn't need to be merged in this resolver function. It's completely done in this execute tree file. This process action output will make sure that needed outputs were run, and here we have some promises chain, and after here we merging payload to pass it down to next branch or next item. Also, parallel actions executor makes sure that it merges all outputs into one before running next item. The issue that could be here is that actions runs in parallel got own input and would be merged once here when finished all of them, and if several of them will try to change the same keys pass on payload, it could interfere. I don't sure how it's done in Cerebral right now.
You can get unexpected results there, and I'm kind of thinking that maybe it should not be possible to override.
We can add here some checks in dev time, for example. I think it could be not just assign, but traversing keys and warnings, to have some warnings that some keys is overwritten.
Because that is actually the problem, the last problem with Fricke now. It's he's overriding props on the input, and it's not working as it used to. So, but yeah, especially as you say, when things run in parallel, you can get if both parallel actions override the same key, you can't make sure that it's overridden the same way. So it's actually a bug, I would say. So we should avoid people doing that.
My initial test was to use that actions run in parallel, or use some array from input and added element to this array and passed next as output. So it was an issue that some parts can't see were merged here. So it just edge case, and I think it should be just avoided.
Yeah, I agree.
I think it's I show almost all. There may be some questions here.
I think I have, because when you show the example with the form, you had the input and the output and set state.
Yep.
But the input and the output and the set state is something that is implemented on top of the action tree. So that none of these, of course, not set state, but not input and not output is actually part of action tree. It's empty.
Input, output, and the output is really part of action tree.
Okay.
But action tree doesn't manage how these things gets action.
Mm-hmm.
It's completely specific to color of action tree client. You can see here. This is resolver passed to execute tree function.
Okay. Okay. So run action is the client passing in how to
run action client, and every time execute tree needs for each action an object with taken path and output payload, which can be empty, of course. Mm-hmm. And here is we manage how run async stuff. We also doesn't pass set state function to async actions. Yeah. Here we can see an timeout stuff. We set timeout. One if action was async.
Oh yeah.
And just clear timeout when action calls output.
Yeah.
Here we just call directly function action function with input output function. Mm-hmm. And set state.
Cool.
All other things done with React. Or re-rendering and other stuff, which is pretty cool.
That's really, really awesome.
I made this demo completely today. For house, I have to change some signatures of interfaces to make it possible. And so you can see it here.
Yeah. Well, but it's really, really cool to see it working and like creating a very concise concept of this behavior tree thing. Like this.
So it could be also extracted to some sort of library which can help component authors to describe some actions.
Yeah.
For wrappers for stateless components and just pass props.
You know what would be really cool if we created a Redux middleware?
Yeah, I also thought about that.
But we can do that. So instead of having set state, you have dispatch, and then
this part could be also replaced with just decorator.
Mm-hmm. We should do that.
Completely all this part maybe just hook around login form here. It's just higher the component, which can manage creating signals from chains. So the really payload here is just chains and actions, which can be split to reusable parts, like we already saw it with Cerebral add-ons. Factor is useful, so we can provide here lot of ready parts like Ajax, etc., etc., etc.
Oh, it's really cool. Looking forward to testing it in the Frick project, and I think like this is a really cool prototype, but if we can make one with like a Redux middleware, that would be very, very awesome. Because this is what it's all about. It's not like making Cerebral this isolated thing that only certain people can use. It's more about sharing all the experiences we have made with Cerebral, because there has been a lot of iterations and exploring and going back and forth and trying to figure out the best way to make this a useful tool. So and this action tree is probably like the most reusable part of Cerebral. So that's really awesome. So have you fallen in love with TypeScript officially, Alexei?
It's sometimes it is getting strange. Some things you can't express just can't find the words.
So you are not completely in love?
Not completely, but I found it completely useful for library.
Yeah.
It's must. I think it's a must-have.
Yeah. Yeah, it's. I think it got a lot of attention. The article Andre Staltz wrote. He wrote an article about library authors should use TypeScript.
No, I don't read it yet.
Oh, you haven't? No, it's.
But TypeScript, my college originally from .NET recommended me. I was a long time be very skeptic about it, but now I see it very useful.
Yeah. Yeah, I was very skeptic initially as well. I got very scared when it was introduced.
You got a point about classes. And
yeah, classes. Yeah.
Some things here was hard about to express chains with functions and outputs. Initially, I got some self-references circular, but managed to do it pretty. Wait a minute. Compact here. I got all interfaces here in one file.
Okay.
And it's describing action. I have to define action func as a separate interface today. So because of this part, I can't know exactly which will be passed to action here. I can't just extend interface which already defines function call at the top, because it merges declarations and use most wide one. So it becomes any in each argument. So I have to use action func here for chains, chain item, parallel actions. It's just parallel actions is just array of action func and action outputs. it can take another parallel actions. We can see here that's part of our
yeah.
Chain item is action func. Action outputs at parallel actions. Why I need this here action func is because I need to define it to force it to be function.
Yeah.
Because all other properties are optional, and if we don't have this function thing, any object becomes valid for a chain.
Yeah.
And it becomes not pretty useful here.
Yeah.
And this part branches section descriptions used by static tree. Action description was cut down to just for these four properties.
Mm-hmm.
I think you can remember action description used in Cerebral. How much it have. I think you remember how we found completely useless pass part. So I was glad to cut it down.
Yeah, this is just an amazing refactor of everything. It's just, yeah, and it's so typical for, like, it started as an experiment, and then it kind of works, and then you fix something, and then you get some users, and then it just, you never get the chance to kind of like, you need fresh eyes to figure out what are the actual parts of this thing and what are we actually using and not using, and so you've done a fantastic work there.
Seems I can be called a refactor guy.
Yeah. But it's a good, it's like, yeah, I thought about this, that Cerebral could never be like, if you were like me, always experimenting with new stuff and just putting stuff in there, Cerebral could never be, because we need to have, fill these different roles where, and often we can change the roles. Like sometimes I'm in the mood to refactor and make something as good as it should be, but you have a tendency to fill that role more often.
Challenge that you accepted was how it was won. You successfully were able to make context provider think first class.
Yeah.
And don't using shortcuts.
Yeah.
I think there is some work there too, but we'll see it after bringing in action tracing in Cerebral.
Yeah.
And one thing I want to discuss with you too. Here, Cerebral has a change event.
Mm-hmm.
It emits before every async action, and emits before parallel actions execution.
Yes.
Here I got read from emitter that was initially here. Also, I got read from callback, and I have only resolve action result functions that can help to communicate with outside. So we can make a signal start, signal end just with emitting before executory and on resolving promise returned by it. We can restore action start, action end by calls to resolve action result, which also can be resolved by promise. And but I can't see how a good way to expose this change thing.
Yeah.
We can use resolve action result here again, but in async we can just check that current item as is async property. But we will get all bunch of resolve action result invokes for parallel action executions. So we will need somehow to detect that they happen as a bunch and emit only one change event.
Yeah, that's a good question.
They will have identical action and payload, all of them. So since it can be detected on client side, this change event.
Yeah, because the most important part about that change event is that
we need to update UI.
Yeah, so if we just trigger it, what we can do is just like we tell Cerebral that we want to make a state change or trigger a change event whenever we find an async action. But then it will kind of like, because you might have multiple async actions, so it might trigger 3 times because you have 3 async actions, but then but that will happen within the same event loop. So we can make sure that we only trigger once, but if that makes sense, because we only want to trigger it when we meet something async or if we are done running the tree.
Yeah, we can check running the tree here. Promise resolves completely.
Yeah. So, but but is it like, do we know that because you have the action index, is that
action index, what do you mean?
I was just wondering if the action index was something you could, because if you have, how do you know that the tree is done running?
Execute tree returns a promise.
Oh, it does. Okay, cool.
Here it is, promise. So it creates a chain of promises.
Oh, okay.
So it starts to traverse tree from 0 index with initial payload, and every time action found, it runs it, process action output for current item. I like readability here. Yeah. Then run.
It's beautiful.
When we get an array, it means that we have parallel actions array. We run all of them, which have its own promise for each action. After we return a result, after we get a result from resolve action result here, we process action output again. When all of them resolved, we merge results and then run next item. And when we get end of branch, we just resolve promise with latest payload. So each action being in parallel, async, not async, every action has this part to process action output, where we merging payload and passing resolving this promise with new merge payload, we get passed to next item, or passing it to output branch and running branch recursively here.
Yeah.
Here we check that if there was object with outputs after action, we check that one of them was taken. So if it tries to go on unexisted or just outputs without taking pass, it throws an error.
Yeah. Yeah, I think we can. I have to like test this, like create the action tree and play around with it a little bit. But my intuition tells me that this change event we should be able to handle it with the current logic here.
Yeah, because change event doesn't fit good to scope of action tree. It doesn't manage state at all.
Yeah.
It just manage input and output.
Yeah. Yeah, I agree.
Or even just payload and that passed through actions being mutated.
Yeah. Well, but that's awesome. I will. I want to. I will set up the action tree in the project, and I will play around with the events, and then I will try to make a Redux middleware.
To put some tests here.
Yeah.
It's completely now. It just tries to use it as model, and no actual checks here happens.
Okay.
It also has own run action function, which pretty dumb here. And used just for make sure that things run.
Yeah. Yeah, there are lots of. Yeah, we have lots of tests that just need some minor changes, I suppose, that we can put into this project.
I think it would be pretty easy to port it because we just has two things to test.
Yeah, good point. Good point.
Just two functions.
Yeah. But this was really great. Now I also got a better understanding of what the different parts here do, and yeah, it looks really great. It does. Awesome.
And finally, in 0 to 35, I think create signal factory file would be able to fit two screens at max.
Oh yeah, that's really cool. but yeah, and this is like from a like marketing, like we're talking about telling other people about Cerebral and what it can do. This is also a really great thing that we have this separate project which has this core functionality of this behavior tree stuff. So we can kind of like tell people about this Cerebral experiment, and one really good thing we got out of it was this action tree, and we moved that to a separate project to let other projects use it as well. But yeah, we have to get this implementation into Cerebral before 1.0.
I'm wondering if it's able to port Cerebral completely to TypeScript, because we also getting TypeScript definitions for free if we use TypeScript originally. And also we get great documentation which can be created with just parsing these definitions. We already have this documentation in code. We can add some JS doc here, which also would help to understand what happens here too. Yep, and here is lib. It's completely generated by TypeScript compiler. It's compiled to ES5 code with common JS modules. It looks pretty readable, yeah?
Yeah.
Creates a signal. Oh, I have the old one here. Doesn't clean. Here is drivers part and execute tree. So we have source mappings. So if we use source map loader with Webpack or any other way, we see original source of components. I even can demonstrate it here. Close it completely. Oops. I haven't managed. I've had some errors today with source map loader, but we can see login form itself, for example.
Yeah.
So it's in TypeScript.
Right.
We can set breakpoints here.
That's cool.
We can debug it here too.
That's really great.
So, and it's very close to original code. It has same names for variables. Not sure about imports. Imports here too, like with Babel, can be observed directly. It has some _1 additions, but still pretty usable.
Cool. But that's good. You have anything more you want to?
I think I'm finished. Oh, here is definitions, which will be also part of package, and every editor would be able to use it to provide IntelliSense. It's pretty cool. Visual Studio Code, great tool for TypeScript, and it could also manage JS files too. It could use typings for JS projects too, but not sure. It does with TypeScript better.
Yeah, and I also saw that someone ported the Cerebral Atom plugin to.
Yeah, I have installed it, but haven't tried it yet.
Yeah.
And we need to check if it works with TypeScript sources.
Yeah.
Should be able to create TS files.
Yeah.
Initially, I also thought that these plugins could use static tree library too, but I got understanding that it needs functions,
Oh.
but to be in chain. So it's not very usable for them. So they use Babel, as I remember, too.
Yeah, I think so.
I'm done.
Awesome. That was really great. Yeah, so we basically have a couple of things to look more into, and that is the action tree and this normalizer thingy. That will be a cool project. And hello. And yeah, so I don't have anything more either. So maybe we should just stop it here, and we hope to get 0.34 out the door as soon as possible, and after that we'll just push on for the 1.0 release. I actually had the first meeting with the designer about the web page, so I'm looking forward to see some stuff coming out of that. So yeah, but let's just stop it there, and thanks guys for showing up and taking part of the discussion and showing off your awesome stuff. We'll talk to each other in a couple of weeks again.
Thank you. Great work, Guria.
Yeah.
Bye.
Bye.
Bye-bye.